All right, today we are learning section 11.2, and as you can see, the problems in 11.2 look pretty much the same as the last problems because we're still just solving systems of equations. We're just going to be using different methods throughout the chapter. And today's method is called using matrices. And it might seem silly. What did I say next? Oh, yeah, it might seem silly to use this method when you could easily use elimination like you already know how to do. But we're going to learn this method on problems that might be easier a different way, so that when you get to ones that would be difficult other ways, you would know how to do this method. So trust the process. Okay, so we're just going to have 3 examples. That's it. So our notes will consist of 3 examples today. And to do this, I'm going to refer you to page 724 in your book. I'm going to show you the steps right here of solving a system of equations using the matrix method of row echelon form. Okay, so I'll explain what row echelon form means, as will will explain what augmented matrix and row operations are. Okay, so the first step is to write the augmented matrix that represents the system. To do this, you simply write a matrix. Did you guys use, I'm going to ask this, how much did you deal with matrices in Algebra 3? Did you do anything with matrices? Like adding and subtracting them, or and then maybe? Okay. In Algebra 2, we do a bit with them. However, we do it toward the end of Algebra 2, where most of you, or some of you, lost that if you had it in the spring 2 years ago. So some of you may have had more background with matrices than others at this point. Okay, but this isn't really going to be too hard. All we're going to do is writing the augmented matrix just means writing these numbers inside of a matrix, which is enclosed with these brackets. I'm going to put a line down kind of where the equal sign is. And that's writing an augmented matrix. So that part's easy. You're just basically writing the system inside of here without the variables. Okay? Step 2 says perform row operations to get the entry 1 in row 1, column 1. Now, what are row operations? It actually talks about that on page 722. Okay? And really, I mean, I'm not giving you the notes on this, because once we do a couple of examples, you'll have it down. You won't need to refer back to your notes, really. Actually, that's not row operations. Here's row operations. Here we go. Row operations. Row operations on a matrix are used to solve. So here is how you could use row operations. First thing you could do is you could change any 2 rows. That part would be easy. So when the step says, I want to get a 1 in row 1, column 1, if this one was a 1, we could just trade them. And that would be the step we could use. So that is a possibility. Otherwise, we have to do one of these other 2 things. Replace a row by a non-zero multiple of that row. That just means you can multiply the whole row by a certain number, besides 0, to get what you want. Okay? And that is what I'm going to do on this one. I'll show the third option when we get to it. But here, if I want to make this 3 a 1, I could just multiply that row by 1/3, or otherwise divide it by 3. So you could think divide, because that's just multiplying by the reciprocal, right? So I want to divide this whole row by 3, and I'm going to show my steps right here to the right. So the way I'm going to show it is I'm going to say, whichever row I'm changing, I'm going to say row 1, so row 1, row 2. Okay, I'm going to say row 1, I'm going to find my new row 1 by taking my old row 1 and dividing it by 3. Okay, so I'm writing to the side exactly what I'm going to do each time, and then below it, I'm going to write the updated matrix. So I'm dividing all these numbers by 3. Now it's 1, negative 2, and 8. And this stays 5, 4, and 12. So I've achieved the first thing. The first thing you need to do is get a 1 right there. Okay? Next. Step 3. Perform row operations that leave the entry 1 in row 1, column 1 unchanged while causing zeros to appear below it in column 1. Okay? If it's just a 2 by 2 matrix like this, that just means there's only one row below it. This 5 needs to turn into a 0. Okay? So I need to leave this a 1 and turn this 5 into a 0. Okay? So I'm going to perform row operations to do this. Okay? Now I can't multiply by 0, right, to make that a 0. So I need to go to the third option, which says replace a row by the sum of that row and a constant non-zero multiple of some other row. This part won't be very difficult either, because if I want to make this a 0, I could multiply this by negative 5 and add it to 5. So I'm going to write that I'm changing row 2 by taking negative 5 times row 1 and adding it to row 2. Okay? Now I'm not changing row 1's within the matrix. I'm just going to multiply by row 1 to add it to this to just change row 2, which is what you can do. So now I'm going to write my updated matrix. I've still got 1, negative 2, and 8 up here. And my row 2 becomes 0 right here, because negative 5 plus 5. Then I'll also do the other. So negative 2 times negative 5 is 10. 10 plus 4 is 14. And then the third one, negative 5 times 8 is negative 40. Negative 40 plus 12 is negative 28. All right? The next step says, to perform row operations to get the entry 1 in row 2, column 2, but leave the entries in columns to the left unchanged. Okay? Now, row 2, column 2 in a 2 by 2 matrix is obviously this number here. We need to get this to be a 1. All right? So again, we could just easily divide. I could take this row 2 and take the old row 2 and divide it by 14, and that'll turn into a 1. Okay, so we've got 1, negative 2, and 8. 0, 1, negative 2. And we have achieved row echelon form. Okay, it gives more steps. It gives a step 5, but that's, if there's more rows and columns than just a 2 by 2. Okay, you would just keep doing it. All right, and step 6 says the matrix that results is the row echelon form of the augmented matrix. Analyze the system of equations corresponding to it to solve the original system. Okay, that means, well, this is y, so we already know y. We could say y equals negative 2. And then we go above. This is x, y, and 8. So now we could plug in the negative 2 and say x minus 2 times negative 2 equals 8, and solve for x. X plus 4 equals 8. X equals 4. So we have solved the system and gotten the answer for negative 2. All right, so that is called matrix row operations method of solving a system. Okay, so again, make sure we've got this down. Do one more 2 by 2 where we copy 2, negative 4, negative 2, 3, 2, 3. Again, your first step is to get a 1 up here. So often that can be achieved by dividing, which was what I'll do again. Take the first row and divide it by 2. So now I have 1, -2, -1, 3, 2, 3. Next step is to get a 0 below the 1. So this is a very similar problem. If we multiply this top row by -3, we'll be able to add it to this one and make it a 0. So I want to change row 2 by multiplying -3 by row 1 and adding it to row 2. So top stays 1, -2, -1. Bottom becomes 0, 8, and 6. -3, so 3 plus 3. And then we will change our row 2. The next step is to make this a 1 right here. So just dividing it by 8, row 2 divided by 8. One, -2, -1, 0, 1, and 6 divided by 8 is 3/4. Hi. So one good thing about this method as compared to, the old-fashioned substitution and elimination is that if you do get a fraction answer like this, it doesn't matter, right, for this. It doesn't make it any harder because this is our answer. So we say y equals 3/4. Plug that back in to our top. We can say x minus 2 times 3/4 equals -1. We have to deal with the fraction here, of course. So that'd be 6/4. X minus 3/2 equals -1. Add the 3/2 and we get 1/2. So we have 1/2, 3/4 as our final answer. Any questions right now before I move on to a 3x3? All right, so the steps for a 3x3 are the same, they just take a little bit longer, right? So, again, step 1, let's go ahead and get this set up. 1, -2, 3, 7. 2, 1, 1, 4, -3, 2, -2, -10. All right, so see if we've got this. Why don't you tell me, Jacob, what step 1 is and what we need to do?
Take row 1, or multiply that by -3 and add it to row 2.
Ah, but what really is the first step?
To get the first line, the first number 1.
Right, which is already achieved, you're saying. So you're thinking ahead now. Is that what you're saying? Step 1 is done on this problem, right? Because the first step is to make this a 1, and we've already done that, right? It's already set up that way, so that's kind of nice. All right? So, actually, before I go on and hear what you had to say after that, I want to ask, what if this, for instance, what if this had been a 4? Okay, what do you think we should do in that case, or should have done, if that's a 4, to get that to be a 1? Go ahead, Emily. Okay, divide by 4 is what I thought you would say, because that's what we've been doing. right? Get that to a 1, divide it by 3. Get that to a 1, divide it by 2. And that we could do. If that had been a 4, I could divide by 4. That would be 3/4, and that would be 7/4, which is okay. Sometimes you can't get around it. You just have to deal with weird numbers like that. But once in a while, there's maybe a better way. You don't always have to just divide. How about another way of making this a 1? So this is just pretending that this is a 4 right here. How else could we make that a 1 without getting any fractions in our problem? Any other thoughts? Well, you can interchange, except that neither of these are 1s. So that may help you do another step, but if this is a 4, just pretend it's a 4 and I want it to be a 1, what's something else you could do besides division? Anybody? Division is not an option. I want this to be a 1. It's a 4. It's a 4 right there. I could use adding or subtract. Go ahead, Mason.
Use multiplication on this one.
Well, multiplication is really the same thing as division. When you say multiplication, what would you have done? Right, which is the same as dividing by 4. So that's not really what I'm looking for here. Jenna? Okay, so you can't use subtraction or addition of just one row. You can't just say, all right, this is a 4, so I'm going to subtract it all by 3. You either have to use multiplication or division, or you can use addition or subtraction of different rows. So you could use subtraction or addition of different rows. Right. If this was a 4, you could take this row here and add it to this row here, and that would make your new row 1 and make it a 1. So I'm just saying that to think ahead, because when that happens, don't always just look for division. If there's an easy way to make this a 1 using addition of 2 rows, you could do it that way. But let's go back to this problem. Okay, so the next step, Jacob, after we get this to be a 1 was what? What do we want next? Don't tell me what you did, but tell me what you want. To get this to be a 0. Yeah. Right, okay, so you have an idea how to make that a 0. What are you going to do? You're going to change row 2 by doing what? And
then adding it to the second row.
all right. Now I could just do that now and then think about the third row, or I could do the third row at the same time. So we could actually change this third row also. Let's just do this within the same step so it'll reduce our steps. So hold on. Don't tell me. Let's go with Ava. What do you want to do to change to make this one a 0? So forget about this. Just want to make that a 0 right there. Yeah, you could do that. You can definitely do that. But I'm just going to suggest not doing that, because you'll end up with 3/2 times 1 plus 2, and you'll have a fraction in there, right? Which, if you like fractions and want a fraction in there, you could do that. But you could deal with the row 1 like we did here and do that again, right? I could say 3 row 1 plus row 3. And so if it's okay with you, I'm going to choose that so that I don't have fractions. Like I said, sometimes there will be some problems where you can't get around that you're going to have fractions in there somewhere. But if I can do it without, if that's an option, I will do my best to not. Okay, so now I'm going to rewrite these. There's my first row. That stayed the same. My new second row is found by taking -2 times my first and adding it to my second. So there's a 0. 4 plus 1, there's a 5. -2 times 3, -6 plus 1, there's a -5. -2 times 7 is -14 plus 4 is -10. Then on this one, they're already opposite signs, so 3 times row 1 plus row 3 becomes a 0. -6 plus 2 is -4. 9 plus -2 is 7. And 21 plus -10 is 11. All right. So there we have it. We've achieved what we need to, where we've got a 1, 0, 0. Remember, the next step said use row operations to create a 1 in row 1, column 2, which before was the bottom right, but now is the middle. Okay? So we want this to be a 1 next. That's our next step. Okay? And I could easily use division here and I won't have any fractions or anything, so that'd probably be the way to go. Just gonna, or I could add the bottom 2, right? It'd be about the same. I could add the bottom 2 and that would be a 1, but I'd say if you could take the row and divide it and still have nice numbers there, that'd be probably the best way to go. Okay, so I've got 1, -2, 3, and 7. I've got 0, 1, -1, -2. And then 0, -4, 7, and 11. All right. So next, after you make row 2, column 2 a 1, then you have to make zeros below it. Okay? So if this was a 6 by 6, which we won't have any, on the test. Don't worry, we won't have any in this class. But one of the advantages of this method is that you could go to as many. I mean, if you tried to solve a system of 5 equations with 5 variables the old-fashioned way, that would not be very fun. That problem might take you an hour. Okay? But with this method, it would still take a while, but it'd be doable because you would just make this a 1, then zeros. Then you'd go down to the third row, third column, make it a 1, then zeros until you got to the end. Okay, so that's kind of one of the reasons we learned this method. In fact, it says in the book 2 reasons why we learned this method. One of them was just what I said, in case it's a bunch of variables and equations. The other one says it consists of repetitive steps that can be programmed on a computer. So people use this method sometimes in computer programming and type this idea in computer programming type things. All right. Anyway, we want to make this a 0 now, so let's do it. Row 3, I would say we'd multiply the middle one by 4 and add it to the third one would be an option. So 4 row 2 plus row 3. Okay, so we got 1, -2, 3, and 7. 0, 1, -1, -2. And now 0, 0. That's -4 plus 7, that's a 3. That's -8 plus 11, that's another 3. So we are very close now. And so we could just take row 3, divide it by 3 to get our 1 there. Okay, so now I have 1, -2, 3, 7, 0, 1, -1, -2, and 0, 0, 1, 1. We have achieved row echelon form. Okay, all right, so now we know our z. That's 1. We could plug that in to the second row. So this is x minus 1 equals, I'm sorry, not x, sorry, y minus 1 equals negative 2. Y equals negative 1. Okay, that was using the second row. And now we could plug the y and the z into the first one. So you're just working backwards. First you'll have z, then you'll get y, then you'll get x. So now I have x minus 2 times negative 1 plus 3 times 1 equals 7. Or x plus 2 plus 3 equals 7. That's x equals 2. So there we have it. X is 2, y is negative 1, z is 1. So it's 2, negative 1, 1. All right, so that is the notes. That's what you need to know. Here is the assignment. It's being altered quite a bit. So, the new 11-2 assignment is page 730. It said 8 to 72 every fourth. We're not going to do that. We're going to do 39 to 44. Those are 2x2s. 51, 59, and 60, those are 3x3s. That should be enough for you guys to have had enough practice on this. So 39 to 44, 51, 59, and 60. All right, here I go. Thanks for tuning in.